GMAT all day.
Hello, and welcome to our video series on lines, angles, and coordinate geometry. This should be the final series in a geometry section. And if you are watching the videos in order, it should be the final video series overall. So congratulations. If you have been following along with our geometry cheat sheet and filling it out, we are here. And these are all the things you should have filled out and memorized once completing the coordinate geometry section. So to start, what do you need to know? You need to know slope-intercept form for writing an equation for a line. And so y equals mx plus b format is simple, but it is also very helpful. So your x and your y values, you can think of those as those are your variables. Those can be any coordinates on your line. And your constants are your m and your b. And so that's really what we're going to focus on here. So m is your slope and b is your y-intercept. And so let's break those two things down, starting with our slope. And so how can you think of slope? What is the slope of a line? So you can think of it as rise over run is a popular way of describing it. But perhaps more descriptively, your slope is really just the steepness of your line, how steep your line is either rising or falling, depending on which direction it is going in. And so how do you get rise over run? Well, to get into that, you have to know, well, what do you need? What are the components of rise over run? What information do you need to calculate slope? And this is actually somewhat useful. In order to calculate slope or rise over run at a minimum, you need 2 points on your line. To calculate slope. The reason I'm writing this out is because this is actually somewhat helpful to know on the GMAT, especially in things like data sufficiency questions. So it might not give you just literally 2 points, but as long as you can get 2 points on your line with the information they do give you, you should be able to calculate slope. And then once you have those 2 points, the way you do it is, so your rise, you can think of that as just your y2 minus y1. So that's the difference in your y coordinates over your run, which is x2 minus x1. Or the difference in your x value. So now it does not matter what you call your y2 or your y1, as long as your x coordinates match up. So your x2 must match up with your y2, your x1 must match up with your y1. So if I have 2 points, let's say it's a 1, 3, and -4, 5. Say these are 2 points on some line. What is the slope of that line? You can say, I will call this here my y2. So that would mean my y2 minus y1 is 5 minus 3. And I can do this as long as my x2 pairs with my y2. So I have to call my -4 my x2 in this case. So x2 minus x1 would be -4 minus 1. And this gives you a slope overall of 2 over -5. So a negative or downward sloping line. You could have done the opposite. So if you wanted to call the 3 here your y2, there's no problem with that. So then we would have 3 minus 5 as a difference in our y values. And we can do that as long as we call this 1 our x2. So the difference in our x values would be 1 minus a -4, which is the same as 1 plus 4. So here we get -2 over 5, but that is the same thing as 2 over -5. Let's talk about the second component of y equals mx plus b format, and that is our y-intercept. And so your y-intercept, that is just the point, or any line if you have some line, the point where it crosses, where it intersects the y-axis. And so the y-intercept, it isn't a number, it's a coordinate. But what it is it's some coordinate xy, but it is, you can think of it, given the equation here, is the y coordinate for when your x coordinate is equal to 0. because when your line crosses the y-axis, the x-coordinate is 0. And so that is why, or that is how I should say, when you plug in 0 for x into this equation here, you just get y is equal to b. So that's why your y-intercept is sometimes just described as being equal to b. So given these two pieces of information, when you have a line in y equals mx plus b format, you might get something like this. So with the values filled in, maybe we'll get this. So y is equal to 3/2 x plus 5. And so this is why y equals mx plus b format is so useful, because when you have it in this format, you can instantly tell a lot about this line without having to do much thinking. And so you can describe this line or even draw it just based on this information. So you know to start, its y-intercept is 5, or 0, 5, I should say. And so you can plot that. That gives us 1 point. And now because you have our slope is equal to 3/2, you can use that to get another point on your line. So when we say rise over run, that means to get it to any other point on the line, so from this single point, from this first point, you just have to go up 3 and over 2. So up 3 and 2 to the right, I should say. So where does that get you to? That gets you to 2, 8. So once you have 2 points, you can just connect those two and get a pretty good idea of what your line looks like. And so based on this, I can tell. So to draw my quadrants here, I can tell that this line should never pass through the 4th quadrant. They like to ask questions like that all the time. I can tell that my line is upward sloping, and you can tell that just from the fact that your slope here is positive. You can sort of eyeball your x-intercept if you wanted to. It looks like it's going to be around -3 or something, but you can also just literally calculate your x-intercept, because your x-intercept is just going to be your x value when y is equal to 0. And so if I want to calculate my x-intercept, just put y equal to 0. Let me get what? -5 is equal to 3/2 x. X is equal to -5 times 2/3, or -10/3, which is -3 1/3. So you can say this coordinate here is about -3.3, 0. What else can you do with y equals mx plus b format? You can, if they ask you, is a point on a certain line, you can say yes or no. So if they say, I'm just going to make up a point here. So if I want to know if the point 614 is on this line, well, how would you know if it's on the line? Well, you can think of your x and y values are sort of your variables here. You can plug in 6 for your x value, because x is your independent variable here and y is sort of the dependent variable. So if when you plug in 6 for your x value, if it gives you 14 for your y value, that's telling you that this point is indeed on your line. So 3/2 times 6 plus 5, 6/2 is just 3. So we get 9 plus 5, which is equal to 14. So 614 is in fact on our line. And if it gave us some other value, 12 or 13 or something, then we would know that point's on our line, but 614 is not. And so one way to show the usefulness of y equals mx plus b format, because you ever wonder, why do people always emphasize putting it in this format? Well, it's the same reason why the periodic table is arranged the way that it is, or why the keys on a keyboard are arranged the way they are. It's because it's supposed to make your life easier. It's for utilitarian purposes. In other words, if I give you an equation like this, this is a linear equation. This is the equation for a line, but it's not super helpful. I can't describe the line or visualize the line or extract much information just from looking at this equation, because I don't know the slope, I don't know the y-intercept or anything like that. So if I'm ever given a coordinate geometry question where they give me an equation like this, the first thing I always do is put it in y equals mx plus b format, which we can do. And so to do that, I will just subtract 3x from each side. That will give you 4y is equal to -3x plus 7. So this is not y equals mx plus b format yet. This is 4y equals mx plus b format, which is not a thing. So we got to then divide each side by 4. That'll give us y is equal to negative 3/4 x plus 7/4, which is what? 1 3/4, so 1.75. This here is more useful. So now I can tell we have a downward sloping line with a y-intercept of 0, 1.75. And I could draw what this line looks like just from seeing this equation. So next, we'll start taking a look at some problems dealing with y equals mx plus b format.